Welcome to a deep dive into MLOps in action, where we peel back the curtain on managing AI systems they've been deployed. The journey doesn't end when a model goes live. In fact, that's often when the most critical operational work truly begins. Today, we'll explore the sophisticated techniques essential for ensuring your AI continues to deliver sustained value and reliability. The post-deployment phase of an AI model is fraught with challenges. Without robust operational practices, even the most brilliant models can degrade rapidly, leading to inaccurate predictions and diminished business value. This is where continuous monitoring steps in as your first line of defense, proactively identifying issues before they escalate. Monitoring model performance is paramount. We track key metrics such as accuracy, precision, recall, F1 score, and AUC, comparing them against established baselines and business KPIs. This isn't a one-time check, it's a continuous stream of data fed into dashboards and alerts, flagging any deviation that could indicate a problem. One of the most insidious threats to model performance is data drift. This occurs when the statistical properties of the input data change over time, making the model's learned patterns less relevant. We detect this by tracking distributions of input features and comparing them to the training data, triggering alerts when significant shifts are observed. Even more challenging is concept drift, where the relationship between the input features and the target variable changes. This means the underlying problem itself has evolved. Detecting concept drift often requires more sophisticated techniques like monitoring prediction errors, A/B testing, or using statistical process control on model residuals to pinpoint shifts in the target concept. Beyond model-specific issues, maintaining overall system health is crucial. This involves monitoring infrastructure metrics like CPU usage, memory consumption, disk I/O, network latency, and API response times. High-level system errors, log anomalies, and resource contention can all indicate underlying problems affecting your AI's performance and availability. When drift or performance degradation is detected, automated retraining becomes a vital strategy. Instead of manual intervention, MLOps orchestrates the automatic collection of new data, model retraining, validation, and even shadow deployment for testing, ensuring models are always learning from the latest patterns without human bottlenecks. Managing multiple versions of models and their associated artifacts is complex. A robust MLOps pipeline includes a model registry that tracks every iteration, its performance metrics, lineage, and deployment status. This allows for seamless rollbacks and rollforwards, ensuring quick recovery from any unforeseen issues. Experiment tracking is not just for development, it's an ongoing process. Every retraining run, every hyperparameter tuning attempt, and every new feature integration needs to be meticulously logged. This provides a complete audit trail, helping data scientists understand why certain model versions perform better and informing future improvements. Pipeline orchestration stitches together the entire MLOps workflow. From data ingestion and preparation to model training, evaluation, deployment, and monitoring, tools like Kubeflow, Apache Airflow, or MLflow orchestrate these complex, interdependent steps into a reliable, automated flow, minimizing manual errors and maximizing efficiency. Data quality and consistency are the bedrock of reliable AI. Implementing a robust feature store ensures that features used for training and inference are consistent, fresh, and readily available. This also prevents feature skew, where the distribution of feature values differs between training and serving. Security, compliance, and governance are non-negotiable in the AI lifecycle. This includes managing access controls, encrypting data at rest and in transit, ensuring data privacy regulations like GDPR or CCPA are met, and maintaining auditable logs of all model decisions and data access. The ultimate goal of MLOps is to ensure the sustained value and reliability of AI systems. Through continuous feedback loops, proactive monitoring, automated maintenance, and systematic lifecycle management, organizations can confidently deploy and scale AI, realizing its full transformative potential. In conclusion, MLOps is more than just a set of tools. It's a culture and a methodology for bringing engineering discipline to machine learning. By mastering monitoring, maintenance, and lifecycle management, you empower your AI to adapt, evolve, and consistently deliver intelligence in an ever-changing world.